All right, chapter 5.1 review, 5.1 and 5.2. Okay, we're going to be just doing problems at your desk today, seeing that you guys understand it. So the first thing I want you to write down is number 50. Great. Okay, make sure you're on page 340. On page 340, what's the first thing that you think you should do? What is the cosecant of 90 minus theta? What is that equivalent to? That's going to be equivalent to your secant of x, yes? Secant of theta here. And what is tangent of negative theta? Okay, so now, what did you say to do? So secant is going to be this, secant of theta divided by negative tangent of theta, right? Do we see that? Now what's secant again? 1 over cosine, I like it. Divided by what's tangent? Negative sine of theta over the cosine of theta. When you divide by a fraction, you multiply by the reciprocal, which means the denominators cancel out there, like you had said. Cosines cancel out. I have 1 over negative sine of theta. What is negative sine of theta? Negative cosecant of theta. Do you see it? Now, your mistake that you had on your paper is you actually had 1 divided by, and you can't do that. You had 1 divided by tangent. That's why you were jacked. No, you just switched the one on the right. Are we good on this one? Okay, again, write this one down. 32 tan of x plus the cotan of y all over the tangent of x cotangent of y. And that equals the tangent of y plus the cotangent of x. Okay, well the point is so you need to remember how to get it. So my question to you is what is your gut instinct telling you to do? Notice that the tangent of x and the cotangent of y in the denominator connected how? By multiplication. Now here's the kicker, guys. This is what I need your brain to focus on, okay? In my numerator, I have a binomial. Would you agree with me? In my denominator, I have a monomial. Monomial means 1. Would you agree? I need it to equal 2 separate things attached by addition, a binomial. Would you agree? So when you have a binomial on the top divided by a monomial, you want to separate into 2 fractions so that you can get the 2 answers over here. So everybody separate into 2 fractions and do it. Tan of x over the whole junky denominator plus the cotangent of y over the whole junky denominator. Yes? What would you do? This cancels out with that, and I'm left with what on top? A 1 over the cotangent of y plus what happens on the second one? The cotangents cancel out, and I'm left with 1 over the tangent of x. Well, tell me, what's 1 over the cotangent? It is tangent of y. What is 1 over the tangent? Cotangent of x. Which, guess what, folks? That's what we wanted, right? Okay, we good? Okay, let's keep going. Let's keep going. How are you liking your boards right now? What are you thinking? Yes, you do two binomials. Do it. Take that left-hand side and split into two binomials. Okay? It's a binomial, and I can take the fourth power and break it down. So how do I break down cosecant to the fourth? So I'm going to go ahead and have two binomials here. This is cosecant squared in the first position. This is cosecant squared in the first position in the second parenthesis. What do my signs have to be? They have to be opposite. One's plus and one's minus. Cotangent of the fourth is cotangent squared of theta times cotangent squared of theta. Agree? Okay. Now, Connor, what I'm seeing right now is this is a great example. He dropped his thetas. Please don't drop your thetas or your x's or your y's, because in the previous problem, if you'd have dropped your x's or y's, you'd have been really messed up, right? Okay? So keep your thetas or keep your x's or whatever's there, okay? If it's all the same, I get that, but I'd really like you to stay in the habit of keeping your theta or your x or whatever. Okay, now what's your gut telling you? Page 340, what's your gut telling you? You're looking at your trig identities, right? You're looking at your Pythagorean trig identities. And on that page, if you look at that, you have 1 plus cosecant squared is equal to what? I'm sorry, 1 plus the cotangent squared is equal to cosecant squared, right? So which one of these parentheses is going to turn into 1? The second one, the one that's minus. Whichever parenthesis you have, you're looking at the one that has the minus. The one that has the minus turns into a 1. Now, what does that 1 do to the other problem? It doesn't change it at all because it's attached by what? Multiplication. So what we have left is the cosecant squared of theta plus the cotangent squared of theta. Do we see that, yes or no? Okay, I'm not done because what do I want? 2 cosecant, I think this is supposed to be a squared. That's supposed to be a squared, y'all, I think. Let me confirm. Yep, it's supposed to be squared, my bad. So I need to get rid of what? I need to get rid of that cotangent squared. So I need to take my trig identity on page 340 and I need to solve that for the cotangent squared because I need to make a substitution, right? So what is cosecant squared equivalent to with that identity? What is it? Come again. I need to solve the identity for 1. I should say for cotangent squared. I need to solve that for cotangent squared. Minus 1. Not everybody was with me on that. So every place I see a cotangent, I'm going to replace that with the value of cosecant squared of theta minus 1. Why did I put that in parentheses? Because I substituted in a binomial in place of a monomial. Yes? Do we all understand that? The reason why I kept those parentheses there is because what if I would be distributing? Am I distributing anything into this one? No, so the parentheses are useless. So now do I have any like terms? Yes, what are my like terms? Cosecant squared and cosecant squared give me how many cosecant squareds? 2 cosecant squared minus 1. Is that what I wanted? Perfect. We good? Okay, again, this is 64. Many of you did not get this right. The directions said to simplify it. It didn't say prove the identity. This is where you guys are struggling a little bit. You're struggling knowing when to stop, okay? Because you have nothing for this to equal, do you? So what's your gut telling you to do with this problem? You cannot cancel them out. But your gut should tell you to FOIL it because it's two binomials. Now, what is your gut also looking at? Whenever you look at this, what's it telling you? They're the difference of squares, so I only have to do what? First and last. So if I do first, I'm going to have 3 times 3, which is 9. And then if I do last, I'm going to have 9 sine squared of x. Yes? Many of you left it here. Am I done? No, I'm not done, gentlemen. Your papers I did not like. Why am I not done? You can take a 9 out. Go fish. Pull out that 9. Pull out that GCF of a 9. So if I pull that 9 out, I'm left with 1 minus sine squared of x. Does everybody see that? Alarm should be sounding in your head. 1 minus sine squared is cosine squared. So this is going to be 9 times the cosine squared of x. Many of you did not get that on your homework. Do you understand why you needed to take that extra step and pull out that GCF now? Make sense? Okay, keep going. Secant squared of y minus the cotangent squared, parenthesis, pi over 2 minus y, parenthesis, equals 1. What are y'all thinking? Why? And what would be tangent squared? This right here on page 340 is equivalent to just tangent of u, okay? Because it said the cotangent of pi over 2 minus u is equal to the tangent. So this is cotangent squared. So can I utilize that still? Yes, I just make it squared. So this is the secant squared of y minus the tangent squared of y is equal to 1. Agree? So you tell me this. Secant squared minus tangent squared. Alarm should be in your head. 1 plus tangent squared is equal to secant squared. So if I put tangent squared and secant squared on the same side, that is going to equal 1, and 1 is equal to 1 then. Right here, 1 plus tangent squared is equal to secant squared, right? So if I bring this tangent squared on the same side as the secant, then I'm going to have 1 is equal to the secant squared of u or y minus the tangent squared. Make sense? Y'all with me? Okay. Yep. Cosine of negative theta divided by 1 plus the sine at negative theta is equal to the secant of theta plus the tangent of theta. What's your gut telling you to do first? You want to use your even and odd identities, right? Bottom of that box on page 340, you want to use those even and odd identities. So what is the cosine at negative theta? No, the cosine at negative theta is positive cosine, right? Now what is sine at negative theta? That's 1 minus the sine of theta. Do we all see that? Okay, now, how is this different than the very first problem or the second problem we did? How is it different than this one? The top has 2 terms on 32, but only 1 term on this one. However, if you look at this one right here, I have 1 monomial at the top and a binomial on the bottom. Jay says to multiply this thing by the conjugate. He's absolutely right. The conjugate of this is going to be 1 plus the sine of theta. Do you know why? We need to turn that top into the binomial and the bottom into a monomial so that we can then separate it into two fractions, right? Because that's what my answer is. Do we see that? So what do you think you should do with the bottoms and the top? Marry them by foiling. So if I FOIL this bottom, the top I'm just going to leave as the cosine of theta times 1 plus the sine of theta. And the bottom, what does that bottom give me? Nikita, what did you just say, honey? If you do this, notice this is first and last only, because there's a difference of squares, right? There's a difference of squares. I only have to do the first and then the last term squared, which is going to be 1 minus sine squared of theta. Now talk to me. What do you notice now? What is it? Cosine squared. So important that you don't forget that squared. So I have the cosine of theta plus 1 plus the sine of theta all over cosine squared of theta. Y'all with me? Okay, talk to me. Absolutely. The cosine on the top goes away completely, and how many cosines am I left with on the bottom? I'm left with 1. So now I have 1 plus the sine of theta all over the cosine of theta. Why am I going to split those apart? Because I need two terms, not one fraction, two terms. So this is going to give me the 1 over the cosine of theta plus the sine of theta over the cosine of theta. Well, folks, what's 1 over cosine? Secant. What's sine over cosine? Tangent. So proud of you guys. You're getting it. How many of you feel like you're getting it? This is from section 5.2, problem 28. 1 plus the cosecant of negative theta, all divided by the cosine of negative theta, plus the cotangent of negative theta, is all equal to the secant. What are you thinking? What are you thinking? Got to get rid of those negative thetas, right? So what is the cosecant of negative theta? That is going to be negative cosecant. What is cosine of negative theta? Cosine. What is going to be the cotangent of negative theta? Minus cotangent, sorry. Cotan. Okay, now things get kind of ugly. Could I do the conjugate concept again? Well, here's what I'm going to say. The conjugate concept's not going to be as easy to do here, and the reason why is because I have cosine and I have cotangent. Is that going to give me a trig identity that I can utilize? No. So do you understand why using the conjugate would not be helpful in this case? What's a dead giveaway here? Can I get simpler than cosine? No. So if I have a term that is in its simplest form and it is a cosine, that's a dead giveaway that you should probably put everything else in its simplest terms of sine and cosine as well. Does that make sense? But before you do that, I would make my life a little bit easier and I would do numerator divided by denominator. Does that make sense? I saw that. So my numerator is 1 minus the cosecant of theta divided by the cosine of theta minus the cotangent of theta. I took this fraction, I wrote it horizontally rather than vertically, keeping parentheses around the numerator and the denominator because we have several terms. Now, I'm going to work my numerator all the way down. I'm going to write this as one fraction. So I'm going to put everything in terms of sine and cosines. So this is going to be 1 minus 1 over the sine of theta, correct? put this 1 over 1 because I'm adding two fractions together. Would you agree? So if I'm adding two fractions together, I need an LCD. What is the LCD between 1 and sine of theta? It's going to be sine of theta. So I have to have the sine of theta here, and I have to have the sine of theta on the second one. Now, my second fraction, I already have the sine of theta, so I drop down the 1. But what did I multiply 1 by to get sine of theta? What, do the bottom? Do the top. So now, do they have the same denominator? So what can I do? Marry them and write it as what? 1 fraction. So what's that going to be? Sine of theta minus 1 over the sine of theta. Sine of theta minus 1 all over the sine of theta. That is what my numerator simplifies down to. Does everybody get that? So now I need to go ahead and I need to continue on with my denominator. So I go back up here and I'm going to be dividing. Now I need to change that cotangent into what? Into its sine and cosine concept. So I'm going to put cosine of theta over 1 because I know I'm going to need a common denominator, right? Minus what's cotangent? Cosine over sine. Okay, so now what? What's my LCD? My LCD is going to be sine. So I drop that down, and I need each one of these to turn into a sine. Notice my second fraction already has a sine in it, correct? So what do? I just drop down the cosine. So now what did I multiply 1 by to get sine? What should do the bottom? So that's going to be sine of theta times what? Okay, now what? Marry them and write it as 1 fraction. So I'm dividing by the cosine sine theta minus the cosine of theta all over the sine of theta. Agree? Now what? Absolutely. Check this out. This has a cosine here and a cosine here. Do you see that? So I need to go fishing. So if I fish out that cosine at the top, I drop down this numerator again. I fish out my cosine of theta, and that's going to leave me with a sine of theta minus 1 all over the sine. So when you divide by a fraction, you multiply by its reciprocal. What is the reciprocal of that? I drop down this junk, change this to multiplication, sine of theta is on top, cosine of theta times this junk. The signs cancel out. Sine minus 1s cancel out, and I am left with what on top? A 1, and what's on the bottom? Cosine. Well, what is 1 over cosine? Is that what I wanted? It absolutely is what I wanted, okay? Do we understand that? That was kind of involved, wasn't it? But do you understand where we went with that and why we did the things we did? Make sense? Okay, this, I'm going backwards, is what they give you. This is section 5.1, the very beginning. This was the easy part where I said, give me the 6 trig functions. This is the tangent of x is equal to 7 over 24, and the secant of x is equal to negative 24 over 25, or negative 25 over 24, sorry. I want all 6 trig functions, given that information. It's like the truck just stalled out, isn't it? Okay, folks, if I am given the tangent, what else do I know? I know that the cotangent is the reciprocal of this, which is 24 over 7. Y'all agree with me? Okay. Well, if I've given you the secant, then what else do I know? Then I know the cosine of x is going to be the reciprocal of that. Would you agree? Okay, here's the, yes. It is sine over cosine, but let's think back even further than that. On the unit circle, what is sine considered to be? Your y value. What's cosine considered to be? Your x. Remember whenever we were given a point and I said now find all the 6 trig functions given a point? What did you have to find when you were given the point? Yes. But you don't have to do that here. What you have to do is apply the definitions that you know. So if you apply the definitions you know that this is going to be y over x because that's what tangent is, correct? You also know that cosine is going to be what? X over r, right? And can r ever be negative? No. Does that make sense? So what does that mean? Where does this negative go? That negative has got to go to the top. So that means my x is negative 24, my r is 25, and my y is what? Y negative 7. But my tangent's positive. So why does my y value have to be negative 7? You have to think quadrants again. Remember that? You got to think quadrants again. Plus, plus, minus, plus, minus, minus, plus, minus. Tangent is positive, negative, positive, negative. In order for tangent to be positive, what quadrant do I have to be in? I have to be in either 1 or 3. But I told you my cosine was what? I told you my cosine was negative, which means my sine has to be negative as well, which means my y value has to be negative. So now that I know x, y, and r without actually having to apply the formula, you tell me, what's my sine value? Negative 7 over 25. So what is my cosecant? Do we understand that? Yes or no? That was a lot of information, but you guys remember what we did with that, right? It's all logic. There wasn't a lot of math there required. What about this? Do it. They're not hard. You can do a trig identity, but you cannot find the 6 trig functions given 2 pieces of information. They gave you 1 trig function, which means they gave you how many trig functions? 2. So what do I automatically know? Cotangent is 1/2. They also gave me something else. What do you mean? Well, we're not there yet, okay? Here's what I need your brain to go to. My tangent's positive. What quadrants do I have to be in? I have to be in 1 or 3 again, because my tangent's only positive in 1 or 3. Then this says that your sine value is less than 0. Well, if your sine value is less than 0, I still got to be in quadrant 3. Yes? So that means my sine value is negative, my cosine value is negative, right? Yes? Okay, now tell me this. What's the definition of cotangent? X over y. So what's x? Negative 1. What's y? Negative 2. Why are they negative? Because they're in quadrant 3, right? Okay? Double negative makes a positive, which is why the cotangent's positive. Now, how do I find r? X squared plus y squared. So that's going to be 1 plus 4, which is going to be the square root of 5, is equal to your r value, right? So can you find your other trig functions now? Absolutely. Do we get that? That means that if it's less than 0, if something's less than 0, what does that mean? Is it positive or negative? It's negative. Where's sine negative? Sine's negative in the 2 bottom quadrants. But cotangent and tangent's only positive in quads 1 or 3, so you have to be in 3 to satisfy both restrictions. Y'all with me? Okay, there's only one other thing that we have to make sure that you are aware of, And I'm not going to do an example of that. It's like problems 19 and 20 where you're finding their mistake. I will give you a problem where you will have to find the mistake in that problem. Okay? When you do it, how do you go about doing that to find the mistake in the problem? Do the problem, but really pay attention to page 340. Okay? Really pay attention to page 340. I have that page already done. It looks just like this. I mean, it's the box completely. I added the sum of cubes and the difference of cubes formulas right on there. Okay? So I would like everybody to be on page, everybody have a seat, and let's look at page 354. And the reason why I want to look at page 354 is I want to walk through with you how to begin. Like, what should we do? You get what I'm saying? So do we all have books? Y'all don't have books. Here. Oh, she has one you can share. Everybody got a book? Okay. Okay. Now, if we look at problem 24, how would you address problem 24? Yes, you are going to use your co-function identities, right? So you plug and check your co-function identities. All right. How about problem 30? We didn't do that, but what would you want to do with that? Could you multiply by something? You could multiply by the conjugate. How about problem 33 or 34? Conjugate again. Conjugate again. Okay. How about number 42? Probably put everything in terms of sine and cosine. Fix one fraction, fix the other fraction, combine them. Agree? Okay, what about 43? $43? 43. One more time, 43. No pulling out. You can't pull out a GCF because the GCF says that each term contains that, right? So it has to go into two binomials. It won't be the difference of squares because they'll have it'll be the sum of squares. The signs will be the same. Okay? What about 44? No, do not distribute. You're going to look at that and you're going to put that into two binomials first and leave that sign of x hanging out there, right? Okay, 44 and 45 and 46. Factor into two binomials and then use your trig identities, right? What about 47 and 48? Conjugate of the denominator. Because I have a binomial on the bottom and I want to turn it into a monomial, right? And I know I can use my trig identities on that. 49 and 50. I'm sorry? No. Sum of cubes and difference of cubes there. Why? Because instinctively you were saying let's use the sum of cubes. Let's go ahead and use the conjugate. That's what you were thinking. Why would you not want to do that on that problem? Because the top part of it is a cube. It's not only cube, but it's a perfect cube. Okay? It's a binomial and each of those are perfect cubes. Okay. Sure. Which one do we want to do? Let's do 50. If you want to go back up to the boards, go. No. Okay, talk to me. So this is going to be the sine of beta plus the cosine of beta times sine squared of beta minus the sine of beta, cosine of beta, plus the cosine squared of beta. All over that junk. It's on your paper. Just apply the formula. I'll have it on your formula sheet, okay? This cancels out, and what I'm left with is sine squared of beta minus sine of beta, cosine of beta, plus cosine squared of beta. No. What is that? What is that? That gives you 1. Because it's an identity. Okay? Test tomorrow. Test tomorrow. Okay? Test tomorrow.